Okay, so, good morning. Good to see all of you here for this presentation. First of all, it's great to be here, to be invited by the organization in Romania. I have to disappoint you a little bit. I'm not going to teach you how to do lockpicking, but I will be doing that later on today. So this presentation is about lockpicking and IT. I've been lockpicking for a long time. I have been picking for over 20 years, and currently I'm the chairman of the Dutch lockpicking organization called Tool. So that's one of the oldest in the world. The German one is a little bit older. And I've been practicing for so many years that I'm actually quite fast at doing lockpicking. So what I'm going to be talking about, if you see a IT system or a lock, you might be intimidated with all the components that are inside, and if you would try to break it, even with a complicated system, it's still possible. This is a lock that I bought when I did a presentation in Switzerland. This is a Swiss lock, and lo and behold, it didn't take me too long to open this lock with the standard lockpicking equipment. And if you are a black hat hacker, you would like to try to get access to data within a company. You could try IT hacking, you could try physical hacking, and I think it's important to understand that you should always use the path of least resistance. So in some cases, it's easier to do the physical route. As a matter of fact, in my day job, I've been doing IT penetration tests for 15 years and doing social engineering attacks and physical pen testing. And I think that in most cases, to get access to the data within a company, doing social engineering, physical pen testing, and then getting access to the data is much more easy than using IT attacks. But the result in the end is the same. And in this presentation, I will be looking at the similarities between IT security and lock security. Right? So in my profession, I'm occupied with IT security. As a hobby, I'm doing lock security. And I thought to myself, well, in IT you have all these classes of problems like design flaws, implementation flaws, user error. Do I see the same stuff in locks? And yes, you do. So the next 45 minutes I will be talking about design flaws, implementation flaws, user error in the lock world. Right. And so it's important to understand that you should take the path of least resistance. So when I saw the ATM machine and it was announced that there were prizes to be won, I headed over and I saw these locks. I actually opened them in less than 20 seconds. So I did have unauthorized money withdrawal using tools of my liking, but unfortunately the guys at the ATM machine said this was not the way it was meant to be played. So unfortunately no prizes for me. Anyway, so in the software development, if you build software, you have the software development life cycle. You start with design of software, then you start implementing it, testing it. And the first problem arises in the early stages of software development when you are designing your software. And I've seen this many cases with our customers that software is being written by people that do not have formal training maybe, or not aware of security issues. So they write software without a security mindset. And then it becomes an afterthought, and that's never very good. It's especially hard in software because if you are a software developer, people will be telling you what kind of software to write, and almost never do they ask you to write secure software. It's all about functionality. They ask you to write some software that performs a specific task. And a specific task. And so security is an afterthought. In the lock industry, this is, and as an example, I've been trying to find examples of these flaws in software and in hardware, and it's actually quite hard to find good examples of software design flaws. So I think in most cases also the problem arises in implementation. But this is an example. This is the Ariane 5 rocket, and it exploded shortly after takeoff because of a design flaw. So they had a floating point exception, and in the design, what they did was to catch each fault and do a full reboot of the system. And actually, in a hardware environment, that kind of makes sense. But if your rocket is going up with tremendous speed and you do a reboot, you're not fast enough to recover the rocket to the correct trajectory. So that's the reason why this rocket blew up. And I think that's a design flaw. Now the question is, do we also have design flaws in locks? Yes, we do. But you might say that's pretty rare, because locks are always there for security. So that's a big difference between locks and software. Software security is an afterthought, and locks, it's always about security. Locks are there to provide security. And also, lock manufacturers are pretty good at understanding the risks and building locks that cater to those risks. And also, locks are in many cases tested, so there's all kinds of certifications. In the Netherlands, you have SKG, in Germany, you have the VDS certification. Locks are pretty simple compared to software, so you can actually do some certification. So these are a few of the risks. So sometimes people ask me, what kind of lock should I buy to use in my home? And then my question would be, well, what are you afraid of? Because there's different kinds of risks. You might be afraid that somebody is going to use lockpicking to gain entrance. Although lockpicking is actually quite hard and it's normally not used for gaining a lawful entry to your house, unless you're maybe the FBI or something. But much more interesting is protection against forced attacks like drilling or breaking, because that's what burglars use. Or maybe against lockpicking, or maybe key control. Maybe you're worried that if you lend your key to somebody, they are able to easily make a copy of it. And you can protect against all of those risks. But to protect against all the risks, that's quite costly, because the lock is very small, and to put in all those measures is quite hard. But there are cases of problems in lock design. So here's an example of a lock. It's actually a two-factor authentication lock. So you need to enter the passcode, and you also have an RFID card to open the lock. And in these kinds of locks that are electronic, the problem is that they need to be fail-safe. If everything fails, the lock should open. So you are able to get out. In case of calamity, there's a fire, electricity goes down, you need to be able to leave the building. And this lock had a problem that, does this work? No, it doesn't work. Oh. Sorry, it doesn't work. Wrong point. Anyway, over there you see a paper clip that's being inserted next to the LED, and this touches the main board of the lock, causes a short circuit, and the lock will go to its default state of being open. So that's maybe kind of a design flaw. And that's actually a class of a type of design flaw that you see a lot in electronic locks. So there's many more locks that you can open by making a shortcut, a short circuit. Here's another one. This lock is an electronic lock. The key holds a desk chip. It communicates with the lock wirelessly, and you need to have the correct key to open the lock, the correct digital key. That works. It's implemented pretty well, but in the end, if you have the correct key, some mechanism pulls down a pin, allowing the lock to open, and that's a metal pin. So the problem with this lock is that you can just use a huge neodymium magnet, hold it in front of the lock, it will also retract the pin, and it will open the lock. And that's also an attack you see over and over again. It's something that lock designers are not aware of, or not enough aware of. So this was in the news a month ago, I think. This is a gun that you can, that learns your fingerprint, or, yeah, I think it was fingerprint, but if you are, no? What was it? Right. So it's RFID, so you need to carry an RFID device that authenticates to the gun, and that will work. But in the end, there is also a mechanism with a metal pin that needs to be retracted, and if you use a big magnet, it will open again as well. electronic locks. This guy made this thing. I also made one. It can be inserted into a hotel lock. It has a connector here, and it contains a small Arduino-like device, and it will talk to the lock using the API, requesting pieces of memory from the lock, including the piece of memory that contains the actual key, and then sends it back to the lock and opens it. So that's also a bit of a design problem in the lock. Another kind of design problem is this: if you have a lock, this is a component within the lock. This is what's actually causing the unlocking. So the latch on top needs to go down to open the lock. Now, in many locks, mechanical locks, there is something mechanical that needs to move. And if you can apply outside force on the lock to induce this movement, you also open the lock. So that's another class of attacks that works on many locks. Here's an example. On the right, you can see what's happening inside the lock. It's actually pretty scary how easy this is. And this works on different locks as well, or on small safes or other devices. Okay, so far design problems. So there are a few design problems, and actually classes of design problems, and if lock manufacturers build new locks, it's wise to test for these kind of problems. Now, implementation error. I think we see that a lot in IT systems. Do we have that in locks? I did find one example. This is a white lock from the Netherlands, and it can be opened using a blank key. So the key has no bitting, but it will open the lock.
But if you insert the blank into the lock, you put a little tension on it, so take the blank out and then turn it like this, the lock opens. And yeah, it's a big design flaw in this lock. Here I'm going to try another one. Another technique that works is put tension on it, pull the key out, stick the tip in, open the lock. Now, as you can see,
I don't think that's a design flaw. It's more of an implementation flaw. So here you see how a lock normally operates. This is a standard 5-pin tumbler lock. The pipe lock works in the same way. So we have pins consisting of two parts. The red parts are the upper pins, and the blue parts are the lower pins. There's springs underneath. What the key does is it pushes down on the pins so they all align perfectly at what is called a shear line, and then the lock can open. Now, with this particular lock, this was the design of the lock, the bike lock. And the design is actually okay, but the implementation is wrong. In the factory, they use the wrong pins. So they have pins, the lower pins, that were slightly thicker than the upper pins. So there was a mistake during manufacturing of these locks. And what happens is if you apply tension to the key, you pull it out, then all the pins have been pushed too far, right? This is a blank key, so the pins are pushed in too far, it won't open. But if you retract the key, all these blue pins will pop up exactly to where they need to be, because they're a little bit thicker. And I've prepared a lock like that here, so I can demonstrate. It has a blank key, it fits the lock, but it doesn't operate. So I apply tension, take it out almost all the way, release a little bit, and demo effect. Sorry, I forgot to do the dance for the demo gods. Oops. On the video it seems so easy. Now, so I'm able now to turn the lock because of this implementation. Of course, this was easily fixed by using the correct pins. Okay, next. What else do we have in IT security? Well, not per se an IT problem, but I think one of the biggest problems with securing your data is the factor of the user, the end user, not being aware of how how to protect information. So it's always a problem. It's interesting, this is a guy, you read about this, he's Nikos Toskas. He was the Deputy Minister for the Interior, responsible for the police and for the country's intelligence agency in Greece. And this was the picture that they put on the official Greece Parliament website. And you can see the posted memo there. If you blow it up, you can actually read that it's password 1, 2, 3, 4, 5, 6. Right, user error. You can make your system really secure, and you can have really secure. This is not a secure password, but if you have a really good secure password, and people will still put it on a posted memo, of course, it doesn't work. Well, the same with locks. Actually, the key could be considered sort of a password for a lock. So you need to be careful with your keys. And here's an example of a news item on NBC in the United States. There were thefts from ATM machines at gas stations. So the ATM machines, they can use your credit card to buy gas for your car. And all these boxes have a lock. And if you open the lock, you can fidget around with the hardware. You can insert a skimmer device into the box. Now mechanics need to have access to all these boxes at all the gas stations, so they all have the same key. So once you have the key, you can open all of them and insert skimmers everywhere. And that's exactly what somebody had done. But NBC made an item and showed this key that the criminals used to open all those boxes. Well, as I said, a key is like a password, so if you see this is actually enough information to figure out the shape of the key and to figure out what the cuts are. Because the cuts, you have discrete depth, maybe 7 or 9. And if you measure those, you can actually build a key. And we see this a lot. We see the TSA keys, for instance, they've been leaked. This was a few years ago. Somebody on eBay in New York sold a key ring with keys that are used to open electrical panels in town, all the elevators in New York, all the traffic light boxes in New York, fireman key, fire alarm box key, and those keys are also the same for all of New York. So if you buy one of those sets, you're in. And the paper, I think it was the New York Times, they printed this picture in the paper and on the website. So thank you. It's really funny that there are actually companies that try to build systems that have a little bit of resistance against this attack of copying the keys by looking at them. So for instance, Keso in Switzerland, they make keys that have holes drilled in that have no use other than to make it harder to look at the key and see what the actual bitting is. So that's nice. So next I would like to show you a video of one of the most famous Dutch hackers, Rob Ongrijp, who is in an elevator at a Dutch Amsterdam metro station, and instead of pushing the buttons for one of the 2 floors, he uses a key, and then the elevator suddenly goes down to a nuclear shelter. You look at this key, what are your thoughts? Sorry? Let's go there. It's easy. Yeah, this is quite a simple key. But the thing is that Rob is not a fool, and this is actually just a key he grabbed from his office somewhere. This is not the key he's using in the video. Which goes to show that if you need to show stuff to reporters, you can just take something that looks similar, and you still have a great item, but you don't show the key. So there's a bit of a backdoor to get access to the shelter. Backdoors. Well, there's a backdoor in an elevator. Do we really have backdoors in locks? We do have backdoors in IT systems. So now we know that NSA tries to backdoor almost anything. They even ask Linux models to backdoor Linux. I find this article from 2003, in which it says that already then the CBS repository of Linux was hacked, and a change was made in the source code that allowed people to obtain root rights, right? Backdoor. They found it, and it never got to production. But still. So do we have backdoors in logging systems? Yes, we do. You see it very often in these kinds of small sets. So I don't know how popular these are over here, but they normally have an electronic lock. And the problem with electronic locks is that you need to think about what happens if you run out of batteries. So you get your valuables in there, batteries are gone, how to open the box? So there is a backdoor. And behind this piece of plastic, if you remove that, you will see a keyhole, and you can use the backdoor key. In this case, it's not, the key is not that bad, but in many cases the key is really lousy, so it's really easy to pick the lock. So you have backdoor access. Even better story about backdoor access is this one. We need to go back to the time when we still had Eastern Germany. And in Eastern Germany, you could only buy state-supplied locks, of course. And these locks actually did have a backdoor. So the German secret police, the Stasi, they were able to enter anybody's home. And the trick is that, so this is a cutaway version of a lock. So metal is cut away so you can see the insides. And remember from the picture I showed you before, each lock has a bottom pins, top pins, and a little spring. You need to align all the pins to be back tight for the lock to open. But the backdoor in this case is the following. They made the space in here big enough to hold the spring, the bottom pin, and the top pin. You can actually push everything down into the lock, out of the plug, into the lock. And then there's nothing left here, and you can open the door. So what you see in the top left, a piece of metal, that's a universal key, so to say. In Germany they call it the Himmelsschlüssel, or the heavenly key, and that will open any lock. So it's funny that some locks that you can still buy, like cheap padlocks, still have this problem. So I just need to make sure that I have a tool with a spacing that's similar to where the pins are in the lock. I need to practice a little bit by putting it in the correct position. And the lock opens. So this is also quite easy with some of the cheaper locks, which I would say is kind of a backdoor. So moving on to keys, crypto. In crypto, we have the problem of key reuse. This is a one-time pad that was used in the Second World War. I believe this is a Russian one. So this is a code to use for your crypto messages. And you may never use the same code twice, because then you can do cryptanalysis and figure out the original messages. So I scratched my head, do we have something similar in logs? Sort of. So again, here you see a standard lock in the closed position. And we have one in the open position where the pins align at the shell. Now, you might see locks that have multiple keys that will open them, master key systems. So you are in a big apartment complex, and the front door will be opened by all the keys of all the people living there, and your own door only opens with your own key. Now, in these kinds of systems, they can be implemented in different ways, but this is a popular way of doing that, which is to cut up the pins in multiple pins. So there's actually more than one possibility for each pin to be in a correct position. So for each pin you cut up in two, you can build two keys that operate on the same lock. And here's one key inserted. That's one of the correct keys that opens this lock. So that's a bit like key reuse in crypto. And the interesting thing is that if you live in such an apartment, so this is the front door key, you can actually take out the lock from the door, open it, so you take out all the pins. You can look at the height of all the pins. And if you do that with a few locks in your facility, then you can, by looking at where the cuts are, you can reverse engineer how the master key system works, and you can actually build the master key for the whole system. So that's because this is reused. Root user. In IT, I think it's quite a big problem that you have omnipotent users that can do anything. Domain administrators, root users. I've done many security tests where you enter a facility and you plug into the internal network and you just try to hack into the internal network, and without much trouble you become domain admin. You have access to anything. What about logs? Well, actually, I've been talking about this a little bit already with the gas pump logs that are all the same for all the gas stations. And you see this a lot. Not many people realize, but there are many places, instances, where mechanics or service personnel need to have access to different kinds of boxes or logs. And they don't want to walk around with 200 keys. So what do? You use the same key for every of those boxes. So I walked around here in the old town and I made some pictures. So this is a phone box, for instance. I don't know how often you see those, but it could be that the lock on there is from the phone company, and once you have one key of that, you can open all of the boxes. So it's like a root user key. Or on the telephones. I must say, by the way, that people in Romania are apparently very honest, because the locks are not very sophisticated as big resistance is concerned. So I think the best ones were on the phone, but still that's not really high security lock, I would imagine. Some boxes were actually not even closed; they were held together with tape. And what was interesting is that many boxes, like the gas boxes, they have this key, so I guess it's quite easy here to gain access to all kinds of stuff. But you see that in many places, like elevator keys, electricity boxes, etc. Sample code. If you are a developer and you quickly need some code that works, you can try and take some sample code or sample stuff from the internet, don't bother about security, and just use it. Now, sample code, in many cases, is not very secure, and the same goes with logs. Yes, there are the sample code logs. If you go to a supplier and you ask for a specific log, well, not for on your home door, but if you want to have an industrial log, say you are building kind of a machine, and it needs to have a key to turn on the machine. So you need a lock for your machine. So you go to the supplier and you say, I'd like to have, I'm building 10,000 machines, I would like to have a lock that I can put in my machine. So they will sell you a lock, but that's a sample lock. The lock is the same for everybody. So the supplier just has a supply of 1 million of these locks that all have the same key. And here's a story from Belgian television. There was this guy who made this item, I will show it to you in a minute, and he got a call from somebody saying, well, if you go to this supplier and ask for a standard cylinder, you get one that is keyed alike. Everybody who buys a cylinder there gets the same cylinder. And these cylinders were also bought by the people who make these boxes that operate the speed cameras.
Over iemand die beweert dat je heel eenvoudig met een sleuteltje de flitspaal op open krijgt en dat je ook die slotjes heel gemakkelijk kan kopen. Ik onderzoek het. Sleuteltje naar. Ja, met die sleuteltjes. Volgens de mailschrijver zit dit in de flitspaal. Dan kan ik met die sleuteltjes de flitspaal openen. Want het geheim van deze paal zit in deze kast. Hier. Dus je hebt hier een slotje. Zie je dit sleuteltje? Doe die niet thuis. Oh.
Actually, I've been told that in Belgium this is actually allowed. It's not allowed to break anything, but if you have the correct key, you can open the box. You can actually switch it off, and that's fine. But I don't want you to do this. Okay, so if you watch this clip, something else that you noticed, maybe? He showed the key. Yeah, remember what I told you about showing keys? He showed the keys on national television. It was actually YouTube. I made these screenshots from YouTube, and this was enough for me to make an educated guess about the exact dating of the key. Actually, I was not sure for one position, so I made 2 keys. I went to Belgium. I don't live far from Belgium. To try them. Yes, one of them did work. So yes, it is possible to use a screenshot to make a working key. Zero days. Yeah, in IT we have 0 days. They're very scary. I mean, right. So this is a graph, the amount of attacks per vulnerability, and at one point the vulnerability becomes known, the number of attacks rises. But this is the time. So the axis is the time. So these are the weeks before the 0 day has been exposed, and it's still a 0 day, and people are still not using it. Of course, in logs you can find vulnerabilities that are not known yet, so then you have a 0 day. One example is this log manufacturer that is actually quite a nice company from Germany. They make logs for which you need to have an RFID tag to open it. And suddenly this video showed up on YouTube. 0 day. This ring is an aluminum ring, and in it are 4 magnets. And I've been told that what actually is happening is that because you're turning the magnet, there's an electromotor inside, and it will generate electricity within the motor, and that electricity then operates the actual lock. So inside the lock there is an electromotor attracting some kind of pin. And you can open and close the lock using this the magnet. It was not a nice experience for the company because this video showed up on the internet, and 2 days later some company was selling these aluminum rings. So I prefer, of course, another form of disclosure, responsible disclosure. And as in the IT world, there's also different attitudes that log companies have. So sometimes the log companies, they say, well, my product is unbreakable. I must say that IT doesn't happen that often anymore. So this is quite an old example of Oracle saying, well, our new version of Oracle is unbreakable. Then everybody starts hacking away at it, and it's not unbreakable after all. So we see that in the log industry as well. So this is Medico is one of the best-selling high-security log vendors in the USA, and they made a new log, and they said this cannot be opened using lockpicking techniques. And there was this guy, Mark Tobias. He spent 6 months together with a friend trying to break the security of this lock. And in the end, all he needed was this thing, and he was able to open the lock in 30 seconds. So that's not very good to do, to tell people that your stuff is unbreakable and will attract a lot of people trying to actually break it. And then, if somebody breaks your lock, it's also wise to handle that in a correct way. Okay? And with locks, not every manufacturer is really good at reacting to security vulnerabilities that have been made public. So remember this lock opens with the big magnet. So that was disclosed to the company, and people asked the company to do something about it. And in fact, they put it on the website, an announcement that their lock was insecure, and people could exchange their locks. After 2 weeks, that was retracted from the website. It was no longer there. Customers were left in the loop. And even then, if you would exchange the lock, you would get the new version, which had one improvement. If you use the magnet, something would break in the lock. It would still open, but it would break, so you could actually detect that somebody used this technique to gain entrance. So I don't think that's a very good approach of doing PR after 0 day. 10 minutes left. Brute force attacks. To hack a password, depending on if you're allowed to do multiple guesses, but you can use all kinds of tools to just guess a password. In logs, that's a bit more difficult. And it's also well, obvious to make it harder to do brute force guessing would be to put more pins in the lock. So you have 6-pin locks, 7-pin locks, or even more. These are incredible amount of pins, so that makes it more difficult. But that's not really a threat because brute forcing a standard pin tumbler, that's not really easy. There's not really tools for that. So I've been discussing this with some people. Could you actually build a brute forcing robot for a standard cylinder? In theory, yes. In practice, I don't know. But for the safe locks, that's very well possible. For safe locks, you need to dial the correct combination, and this dialing can be done using an auto dialer. This will take maybe a week to open your safe, but in the end it will work. And you see a lot of people now, hobbyists, making auto dialers themselves from cheap components. But it's actually not a big problem because those safes, they are meant to deter an attacker for a certain amount of time. So if it takes a week to open a safe using an auto dialer, that's not really a threat to most people who have a safe. DDoS service attacks, very easy in IT, also very easy in locks. You don't see them often, luckily, but with a bit of super glue, it will get you already pretty far. There's actually special keys that you can buy, lock busting keys, that are specially designed to break your lock. So you insert them, because of the shape, you cannot really retract them, and also they are weakened here, so you can easily snap off the top of the key, so this inner part stays stuck. And your lock is inoperable. Sequential attacks. If you try to guess a username and a password, in some cases you can do it sequentially, right? So if you get a different error message if you give the wrong username or the right username with the wrong password, you can first guess a working username and then start guessing on the password. Now this also works in locks. So sometimes you have more than one row of pins. So this ASA twin, for instance, has 2 rows of bitting operating on 2 rows of pins, small pins and bigger pins. And with all these locks that incorporate 2 mechanisms, it's always the case that one of the rows of pins will be the first to block the lock. And you can try to lockpick that row, then it will turn slightly, and then the next row will block, and you have to pick those, so you can actually do them in sequence. So if this lock would have 5 big pins and 5 small pins, it's like picking a 10-pin lock. Still, it's very hard, but it can be done. So this is how it works. And there are several ways of doing this. So this is the EVA 3KS. It uses pins on the side, and it also has these grooves operating on sliders. So here you can see how the sliders operate. You do first one, then the other. There's another system, it's from Medico. They have keys that are cut in a certain depth, but also in a certain angle. And the pins, they have a groove in them, and the pins need to rotate and align for the groove to align with this pin that needs to go into the red pin. So here you can see it again. It turns, the purple part goes in, and it opens. So you can do that sequentially. If you build an IT system, you would like to know how secure it is, you need to do some testing. So it's always a bit difficult. What do? You use automated scanners that will be cheap, give you some kind of idea. Do you experience security consultants and stuff? How do you know what kind of quality a person gives you? Certification, still a problem in IT security. In logs, it's a bit more easy. In logs, we do have working certification. And this is a funny story. This is a German log from doers manufacturer. And they wanted to have this log certified in the Netherlands. And the way that certification works is that a security test lab gets the log. They have a set of tools, and they try to open the log in any which way they like, or in any which way that has been written down that they are allowed to try. And then, depending on how long it takes to open the lock, they get 1, 2, or 3 stars. Actually, 1 star means 2 minutes, 2 stars is 3 minutes, and 3 stars is 5 minutes of resistance. So that sounds like a very short time. But actually, if you're a burglar and it takes you 5 minutes to open the lock, you will move on to the next house. So actually, the certification does say something. So, but in the Netherlands, they tested this lock, and they were just a few seconds short of getting 2 or 3 stars. A few seconds short of getting 2 stars. So they altered the lock, and this is the Dutch version. And you can see Dutch version has an SKG certification with 2 stars. So what's the difference between the German one and the Dutch one? Sorry? Small hole. Yeah, it's actually a ball bearing that's put in here, and that's the difference. So the dome guy from Germany and the dome guy from the Netherlands, they were in the bar discussing how to get the few extra seconds of resistance. And also you want to implement this in a way that is as cheap as possible. And they got this idea to drill a little hole and push in a ball bearing. It was really cheap. Drilling a hole is cheap, ball bearings are cheap. And this helps when somebody tries to use a drill to drill through the lock. So the drill cannot drill through the ball bearing. So that gave them a few extra seconds to get the certification. Don't riddle this just as the tooling gets better in IT security testing, and the knowledge you need to do tests drops. So it becomes much more easy, becomes easier and easier to do security attacks. And that is something that is now also happening in the log world. And it's really interesting to see what will happen. Because the log world has been the same for a long, long time. And just now they start to wonder about what's happening on the internet. And people do lockpicking and talking about logs and vulnerabilities. And it's completely new to the log industry. And also the tooling gets better. So now you have apps that you can use to make a picture of your key, and you get a duplicate sent home. Well, I wouldn't send it to my own key, but... Or you can use molds to pour metal in to make a duplicate of a key. That works for many, many high security keys as well, if you know what you do. And 3D printing, of course, is getting better and better. So, yes, it is possible to 3D print a key. And so the problem is that if you have a key that has a shape that is protected by a patent and by a certificate, then now you can just print the key. What makes it a bit more difficult is that you also have keys with movable elements. So a key on the top, there is a piece of metal inside of the key that is movable. And it actually needs to move for the lock to open. So if you take it out, the key no longer works. And of course, it's pretty hard to print a movable element within the key. But we're not there yet, but people are experimenting, and we're close to being able to print quite a lot of keys. And security, well, in IT security is invisible. You can't really tell how secure the system is, and you get what you pay for. If you don't care about security and want the cheapest solution, you get something that's insecure. And not everybody is a security expert, so you don't know that you're missing the security. And in logs as well. So logs are physical, you can see them, you can have your own ideas about how secure these logs might be. But does it really mean anything? So these are logs that we actually used in a competition in the Netherlands. Yes, there are lockpicking competitions. So we were allowed to try and open these logs using the lockpicking tools. And I have to say that we were also allowed to then keep on picking them and improving our times. So it's not the first time that counts, but after repetitive trying, the fastest time counts. But so who thinks that this is the hardest to pick? It takes the most time. This one? That one? This one? Okay. I'll show the actual times that we did. So yes, the malware, this is, by the way, minutes, so 4 minutes, 49 seconds for the malware. But as I see, I have 34 seconds. And this was a lucky shot. It could be that one lock that you buy has a different pinning than the next one in the batch, so maybe this we got a little bit lucky, I don't know. But so you see that by just looking at the log also you cannot really tell much about the resistance against lockpicking and other techniques. And I already talked about end users awareness is a problem. So this is really funny. This was a thing at the security conference where you could charge your phone, but of course it doesn't just charge your phone, it just retrieves all information from your phone. And people there were actually still using it. And this ATM machine that was at the DefCamp that was carried into the casino, and nobody knew who did this. So awareness is a problem. People are not aware that they should not be showing keys to other people. And this is really interesting. This is a lock I bought in the Netherlands for €1.50. So I don't know how many related that is, but not that many. And this lock is so bad that it does work with the correct key. I have a second one. And the key does not work, so sounds good. But if I take it out a notch, it still works. How is this possible? Actually, if I use the wrong cylinder and take it out a few notches, it also works. So it's mind-boggling how bad some locks are, and also mind-boggling that people are actually using those keys on doors. So bottom line is you actually need a holistic view. You're not just depending on the lock. It's the same within IT. It's not just about doing IT security, because somebody can just walk into your facility and get access to your physical data center. It's game over. And the same with locks. It's not just the cylinder, but it's the whole system around it. Your security is the weakest link. And in fact, I haven't been talking about all these kinds of things. That would take me another hour. But there are all kinds of tricks to get into a facility without actually circumventing the law. Right? So in the end, I think it's really important to do threat modeling, to think about what the risks are, and figuring out where to improve the security. And it's the same within IT security as with physical security. So I'm almost at the end of my talk. Afterwards, I will be heading down to, I think it's the Hacking Village, or the first hall. There will be a table there. I have some locks, I have some lock picks. I will do a short introduction on how to pick locks. And you're all invited to join me and try and pick locks. If you want to reach out to me or want to know more about physical pen testing, there's this other talk that you can watch online, or you can contact me via email. So, question time.